Welcome to Brain Vision.
For this question, we want to use Z equals 2 for helium plus and assume the Bohr's model of the hydrogen atom. The reason we can use Bohr's model is because helium here is ionized, so there's only one electron. What is the ionization energy for helium plus? That's part B. So for part A, to draw these energy levels, when Z is equal to 2, we're going to consider the fact that our equation governing the Bohr's model version of energy levels for hydrogen for helium plus, we can call it E sub n for the different energy states, is equal to negative 13.6 electron volts, which is the ground state energy for hydrogen, multiplied by Z squared. Since we aren't just dealing with one proton, we have more than one now. We have two in this situation, divided by n squared. So for us, plugging in Z equals 2, this is equal to negative 54.4 electron volts divided by n squared. So now we're going to draw out these different energy states for this value. Of course, when n is equal to infinity, so we'll on the left here, we'll have n. On the right, we'll have E in units of electron volts. When n is equal to infinity, we'll just plug in infinity, and you have negative 54.4 electron volts divided by infinity, which is going to be 0. Okay. Now I'm going to start with n equals 4. You could, of course, write in a bunch more, but let's just start with n equals 4. So if you plug in 4, you get negative 3.4. How about n equals 3? N equals 3, you get negative 6.04. And then n equals 2, we get the exact same as the ground state for hydrogen. It's going to be down even farther. You get negative 13.6. So that's our solution for A. Part B says, what is the ionization energy of helium plus? Okay, so to calculate the ionization energy of helium plus, we're going to take, we call this delta E. This is equal to our ground state energy, which is negative 54.4 electron volts, since that's what our value is when n is equal to 1, multiplied by 1 over the final state. Well, it's ionized, so the final state is infinity, minus 1 over the ground state, so this is n equals 1, squared. You also could square infinity, but infinity squared is still infinity. So plugging these values in, we find that the ionization energy, of course, is just 54.4 electron volts. We can box that in as our solution for part B.